So we were going to today we will be having size 8.3 and we completed 8.2 in our last assignment and last class. So let's go. So if you can see the first one, write the order of differential of the family of circles. So we have an equation of circle as x square plus y square gives a square, and we need to determine the order of the differential equation. So we can like solve this and make the differential equation and then answer, but there's a direct answer to it. The order will be, can you tell what will the order?
The order?
Yeah. This is like you were in the previous exercise, you were given a value of y something and we were making a differential equation from it, right? So this was the solution and we were making a differential equation from the solution. So this is similarly like that. See, this is like y square equals a square minus x square. So we are given a value of y. Now we have to make a differential equation. So this will like make some differential equation. So whatever the differential equation is, the question is asking what is the order of that equation. So we need to determine the order of the differential equation that this equation corresponds to. So this is the equation of circle with radius a and center is 0, 0. So this will correspond to some differential equation and we have to determine the order of that differential equation. So what can be the order of the differential equation that the circles represent?
Is it 1?
Yeah, why 1? Why not 2?
Because we only have one arbitrary constant.
Yeah, so we can look at the arbitrary constant and just determine it. So for the practice, let's make a differential equation out of it too to check our answer once more. So when you differentiate x square, you get 2x and this is 2y dy by dx. And here we get 0. So this is dy over dx gives minus x over y. So this is the differential equation, or you can just cross multiply it to get y dash plus x equals to 0. So this is the differential equation that is represented by a family of circles. Like why are we saying family of circles? Because we are not sure which circle are we talking about. There can be a circle of radius 5 units, 6 units, and because a is arbitrary constant. So the differential equation that represents the family of circles is this y dash plus x equals to 0. So you can see the order is here 1. Okay, so our next question is write the order of differential equation of family of parabolas. So here also we have only one arbitrary constant, so the order will be 1. In the third part, we write the order of differential equation of family of parabolas. I square equals 4ax minus b. So in the third part, what will be the order? The equation is I square gives 4a x minus b. So now what will be the order?
Order will be 2.
Yeah, order will be 2 here because we have two arbitrary constants a, b. So until now we are given a solution and we are just verifying whether it is a solution, or from the solution what we were doing till now, from the solution we were making a differential equation.
Yes.
Right? This is what we were doing, or in some cases we are just confirming whether a solution is for a differential equation, particular differential equation or not, by just substituting the value of y dash or some y in it and then solving the left hand side or our right hand side. So now in this exercise also we are going to do the same thing. We are given a solution and we have to make a differential equation. So in the second question we have straight line equation, that is y equals mx. Now we have to make a differential equation out of this. So this is pretty simple. We have only one arbitrary constant. So which type of line is this? Does this line have any particular property? Any characteristic that just pops out when you see y equals mx? So this will be a line which will definitely pass through origin. It can be like this or it can be like this.
Yes.
Yeah, because we don't have any y intercept. So y intercept is 0. So that means the line is passing through origin. So when you differentiate it, you get y dash gives m, right? And you can just put back the value of m into our solution to give y equals y dash x or y dash x minus y equals to 0. So this is free from arbitrary constant. So we can say that this is the differential equation for family of straight lines.
Okay.
So next one is also similar, x square plus, we have done this before. This is the family of circles and we have to make a differential equation. So what we have done it before. Let's skip this. And fourth one is form the differential equation not containing the arbitrary constants and satisfy by the following conditions. So let's do some of these parts. This is 4. So we have a question like this, y equals ax cube. So here also we can just differentiate once to get y dash 3ax square, and we can determine the value of a here, that is y dash divided by 3x square, and just put back the value of a into our solution to give us y equals y dash by 3x square into x cube. This will give us y equals y dash x y dash by 3, or 3x y dash minus 3y equals to 0. So this will be the differential equation. So again, we have a similar equation of circles, like circles. It's just that it's y square minus x square minus y square. So we'll skip this one also. Next, we have parabola, that is y square equals 4ax. You have, I guess you have done this in your assignment, right?
Yes, sir.
Y square equal to 4ax.
Yes, sir.
So we'll skip this one also. Next, we have fifth question, which was, this was the one that you got wrong. This was x square plus y minus b to the whole square gives 1. So you will, when you like, let's do it your way now. First what you did was open the bracket. So y square plus b square minus 2yb equals to 1. Now differentiate to get 2x plus 2y dy over dx minus 2b dy over dx. And here we have 0. So now what we can do, we can, okay, so we can take the 2 common from every term, and let's determine the value of b. So we can write 2b, b dy over dx equals to x plus y dy over dx, right? And if we determine the value of b, then dy will be upon, so okay, let's see, b is x plus y dy over dx whole divided by dy over dx. So let's substitute the value of b back into the equation. So you see this, like if you're doing this way the question can be solved also, but you'll have to do much more simplification to get the final result. So y minus x plus, let's write it as y dash by y dash, and this is whole square gives 1. Now we have to simplify it a little bit. This is y dash. So we get x square. If we, okay, some terms will be, okay, so take the LCM, get y dash minus x plus, this will also change to minus y dash whole divided by y dash square gives 1, right? Now this y dash cancels out, and when you whole square the minus x by y dash, you'll get x square by y dash square. This is now looking similar to what we solved earlier, equals 1. And then you'll multiply the equation by y dash square to get, and take x square as common, so get 1 plus y dash square gives y dash square. So I believe this is, let's see what is the answer. So x square y dash square plus 1 gives y dash square. Okay, so see the method, whatever method you can apply, as long as you are doing correct step, you'll get your answer correct. So what was the best optimal method to do this was just determine the value of y minus b. Like when you, if you differentiate it directly, you'll get 2x plus 2 times y minus b dy by dx gives 0. And then you can just solve for y minus b. So y minus b will be minus x divided by, let's write it as y dash. This will be like y minus b. And you can just substitute y minus b over here. And when you do that, you'll just reach at this step here. If you substitute this into the equation, you'll get x square plus square of this, which is this term here, and 1. So you just completely missed all these steps and directly got an answer.
Yes, sir.
Okay, let's do. So fifth part 2 is also completed in our assignment. Let's do the sixth one. It has two variables. So we need to differentiate it twice. So the sixth one is x over a plus y over b gives 1. So definitely as soon as we saw that the equation has two arbitrary constants, we are going to differentiate it twice. So before differentiating, let's solve it a little bit to get bx plus ay gives ab. Okay, so to do this directly, like you can see the denominator has a and b. So what is the LCM of a and b? Like two different numbers, it's their multiplication. Like what's the LCM of 2 and 3? It's their multiplication, 2 into 3. So the LCM of AB is A and B is AB. So you multiply whole equation by AB. So when you multiply AB here, A cancels out and you get BX. Similarly here you get AY and AB. So now let's differentiate this equation. Differentiate this equation to get B plus A dy over dx gives 0. And so we can just like eliminate both of these at once. See, we can write A dy over dx gives minus B, and we can write then dy over dx gives minus b over a. Now you see both are like constants. So if we differentiate this equation again to get d2y over dx2, this will be 0. So you can get differential equations like this also. Let's check the answer. Sixth one is y2 equals to 0. So this is the differential equation for this curve.
Yes, I got it.
Okay, seventh one is we have also done in our like last class, I guess. It's similar to like parabola. We have y square gives 4a x minus b. It's similar to parabola, it's just that we have two variables here. So let's again do this also. So let's write it as 4ax minus 4ab y square. So 2y dy over dx will give us 4. Like 4a is a.
Yes.
The question is y square equals 4a x minus b. Okay, that's right. So we can like differentiate again because now the constant is without any variable. So we can just differentiate again. This is y dash equals to 2a. Now we differentiate. So we have to use the product rule. So first differentiate y and keep y dash as it is. So you get y dash, differentiation of y is y dash. Then you take y as it is. And when you differentiate y dash again, you get y double dash. And this is 0. So this becomes y dash to the whole square. And this is y double dash equals to 0. Okay, so seventh one is y2 plus y1 square equal to 0. So this is y2 plus y1 square. Okay, right. Let's see our eighth. So eighth one says y equals a e raised to the power 2x plus b e raised to the power minus. Yes.
Sir, I didn't understand after this step y dash is equal to 2a.
Okay, from here now.
Yeah.
Okay, okay. So this is y into y dash gives 2a. So we have two y's and we are going to differentiate it y into y dash. So this is like the composition of the product of two functions. So we have to differentiate y once and keep this y dash as it is. So we keep a y dash as it is, this one, and we differentiate this y. So when you do dy dx of y, so this will be like y dash is as it, and you do dy dx of first, and this is second. So we write second term as it is, and we differentiated the first term. Then we write the first term as it is, and we differentiated the second term. So
Oh,
what is second term? Second term is y dash
y
itself.
dash.
This is dy by dx itself, and we are going to differentiate it once,
D by dx. Yeah, I get
right?
it.
Yeah, so
Yes.
now this becomes y square because this d2y, this is y d2y by dx2,
Got it,
dx
sir.
whole square. And okay.
Thank you, sir.
Uh, Okay, let's. So last question is y equals a e raised to the power 2x plus b e raised to the power minus 2x. So here also we have two arbitrary constants. So let's differentiate it twice. Okay, so this types of questions are like once you do two or three types of questions like this, you'll get it. So differentiate it once, and when you differentiate it twice, the equation will become same again. See,
Yes,
so
sir.
differentiate once, so you get y dash and a 2a e raised to the power 2x, because e raised to the power 2x is e raised to the power 2x, and the differentiation of 2x is 2. Similarly, here we'll get minus 2 b e raised to the power minus 2x, right?
Yes, sir.
So this is our differentiation one. Let's differentiate it again to get y double dash gives, now this will become 4a times e raised to the power 2x, and minus and 1 minus from the power will make it positive and give us 4b raised to the power e to the power minus 2x. And then we can just common out 4 and e raised to, I guess this was also on your like assignment.
Yes, sir. I was in the assignment. I could
Yeah,
do
yeah,
it.
yeah. So this is just 4y. So y double dash minus 4y equals to 0 is the differential equation here. So you see this exercise was also the extension of the second exercise itself. We have doing similar things, not something new here. It's just that the we are given with the names of the curves here, like parabola and circle and some exponential curves. So let's see what is next. So do you have any questions in this exercise 8.3?
Not really, sir.
Okay, okay. Okay, so let's see. We'll do next exercise in our next time, but let's prepare what we are going to learn in our next class so that we can just start from the exercise. So right now, what we are learning, we are always given a solution like this, and we have to either make differential equation, or we have to satisfy the solution into the differential equation. Now, what we are going to learn is how to solve a differential equation. That is, we were now giving they will now give us a differential equation, and we have to like determine the solution what we were getting in our previous questions. So now we have to solve a differential equation to get a solution in the form of y equals something. So there are multiple ways depending on the differential equation, how a differential equation is. You can apply different methods. So the first method is for the differential equations that are of the type like we studied it earlier, variable separable. The first method is variable separable. So the name itself tells us everything that if a differential equation is built like this, that we can separate the variables on one side, one variable on one side, like say independent variable on one side and dependent variable on the other side, then we can use this method to solve the differential equation. So let's take an example and do this. So we have, let's say, e raised to the power x plus e raised to the power minus x dy over dx gives e raised to the power x minus e raised to the power minus x. So we have a differential equation like this. So clearly we can see there are no y terms here. So we can just take x to one side and keep dy over here. So we can write dy as e raised to the power x minus e raised to the power minus x divided by e raised to the power x plus e raised to the power minus x, and we can write dx here, right? This
Yes, sir.
this comes out in the denominator, and dx just comes. So now what we can do, we can simplify this a little bit further before like integrating it, or we can integrate it like using the substitution method. So let's see. So next step is integrating both sides. So integrate dy and integrate e raised to the power x plus. So here we can see if we here is negative. If we differentiate the denominator, we are getting the numerator.
Yes, sir.
Right? If we like, let's say, let u is e raised to the power x plus e raised to the power minus x. So what is du? Du is e raised to the power x minus e raised
Minus
to the power
dx.
minus x dx. So in place of numerator, we can write du, and in place of denominator, we can write u. So this becomes du
By
over u. This is just dy. Now we can integrate both sides to get integration of dy is y. 1 upon u is log u and plus c. Now an integration, the variable name doesn't matter. Like if you have a function fx, this is 2x plus 3, and if you replace a variable, like let's say this is fu tu plus 3, so is there any change in the original value of the function? There is not, because
Yes.
whatever the value of u, you can give like x equals to 1 2 3, you can give same values here and you'll get same answer. So it doesn't matter if the name can be changed. So we can write this as y equals log x plus c also. And yeah, one more thing, when you're getting only one log, like let's say if we were getting dy over y here also, and we were getting like log y equals log u, so we are going to take the arbitrary constant as log. We are going to take the constant as log c. Okay, the question will come, we'll see. But whatever the type of equation is, like let's say if this equation is completely logarithm equation, y is log, u is going to be log, so where we then take constant also as a log. So we'll take log c as constant.
Okay.
Okay, so these examples are good. Like we can do these.
Yes, sir.
Let's
Well,
let's take. Okay, let's take this one. So the question is that the differential equation is dy over dx gives 1 plus x plus y plus xy, given that y is 0 when x equals to 1. Now we have to determine the particular solution. This one is asking that determine the particular solution. So what we are going to do, we are going to just solve for general solution, and at the end, whatever the given condition is, we'll apply them and determine a particular solution. So the given condition is y is 0 when x is 1. So let's see. So here we have like 1 x y x y. So we have a non-linear term xy. So we can take common as 1 plus x here in both this term. Let's write it like this, plus y 1 plus x. Now we see that 1 plus x is common in here and here. So we can write like 1 plus x times 1 plus y gives dy over dx. Once we have done this, we can just do variable separable to write it as 1 plus y gives 1 plus x dx. Right. Now we can just integrate. So 1 upon 1 plus y is log y, and 1 plus x is x plus x square by 2 plus c. So this is what comes out of this is what we get as general solution. So if it was asked that determine the general solution, we'll just stop here. But here we have to determine the particular solution. So given condition is that when x is 1, y is 0. When x is 1, y is 0. This can also be written as y1 equals to 0. Sometimes it will be written like this. So this thing and this is same. Like it says y of x is something. This is the condition. So you get x value here and you get y's value here. So let's apply this condition. So we get y is 0. So we get log 0. And here we are substituting 1. So 1 plus 1 by 2 plus c. Wait, this was 1 plus y. So here we get log 1, and log 1 is just 0, and 2 plus 1 3 by 2 plus c. So we get c as minus 3 by 2. Now what we'll do, we just substitute this value of c in our general solution here to get the particular solution. So the particular solution will be log 1 plus y equals x plus x by 2, x square by 2 minus 3 by 2. This will be our particular solution.
yes, sir. Well,
Right, so so next exercise 8.4 will be based on this, the variable separable method. So it is quite easy. You just have to simplify the equation such that the y terms can be arranged on one side of the equation and the x terms can be arranged on the other side of the equation. And then you have to integrate both sides to get the final result. So
yes, sir.
just have a look at the examples that are given here. Examples are very important. Most of the students that I know skip examples and they just do exercise questions, but examples are very important. Sometimes a more important question lies in examples. When you see NCRT, there are more, like some chapters are there in which the examples are really good. Like the trigonometry one, there is one very good example. So always do examples also. If you see that it's like very easy, so like you can just go through it once to see the steps and understand like what's going on in the question. But if you think that it's gonna like give me a problem anywhere in the step, then you must solve this.
Yes.
So try to do these examples and we'll do the exercise in our next step. And one more thing, there was a question missing from the assignment. It was order and degree one.
Oh, yes, sir. The first one. I did the first one once, but then I couldn't do the other three because I got confused.
Okay, you must like tell me. So we'll do it right now.
Yes, sir. Actually, I wanted to tell you, sir, but my mic wasn't working, so I just like forgot about it.
Okay, no worries. So let's see if we can bring this to our board. Okay, so what was the first one's answer?
Oh, so first one's answer is order is 3 and degree is not defined.
Degree is not defined. Why?
So because e to the power y.
Yeah, because exponential e raised to the power x is something like 1 plus x plus alternating series minus x square by 2 plus something. So when you see the powers of x are continuously changing, so we have y dash here. So when you substitute y dash, you'll get like 1 plus y dash minus y square, y dash square by 2, and then you get another power of y dash. So it's not, it's looking that it's not defined. The y dash has multiple degrees here. So this is not a polynomial. This is not a polynomial in derivative. So that's why degree does not exist. So in the next case, what is the degree and order?
The degree is, so the order is 2.
Right, order is 2.
And the degree, I'm not sure.
Okay, so right now, if you see at this question, it's saying that I do not have a degree because I told you like the exponent can't be a fraction. It can only be positive integers like plus 1, plus 2, either plus 0, but plus 0 will just give us 1. So plus 3, plus 4, like that. So if it has a number other than these numbers, then the degree will not exist unless you can just simplify the equation to get a positive integer as an exponent. So we can just what we can do, we can cube this, cubing both sides.
Yes.
So why we are cubing? To get the rid of 1 by 3. So we'll get 1 minus dy over dx to the whole square to the whole cube gives a cube d2y by dx2. Now you see we are looking for when we are going for order, we are looking for this. So we don't have to open this term here because we know that no d2y by dx2 will come out from here to like do anything. But if this was not present, like say this was absent, then we have to solve this 1 minus dy by dx ka whole square to the whole cube. We have to uh, open this whole cube and just simplify, and then at the last step we'll see what is the highest power. So in this case we'll get what, 6.
Yes, sir.
Right, a cube minus b cube minus 3ab a minus b, so we'll get b cube term which will give us 6. So if the second derivative term this was not present, the answer will be order is 1 and degree is 6. But here when you like solve this, so you get order is 2 and degree is 1.
Okay.
Similarly we can do this also. Now third one, we can just take power 4 both sides.
4 by both sides.
Right, so obviously this will not affect, but what is the order and degree here when you'll take power 4 both sides?
It's order is 2 and degree will be 4.
Yes, degree will be 4 because we'll get 4 here and we'll get 1 here.
Okay.
So we're going to look for this because this is of higher order. Okay, next fourth. What is the order and degree?
The order is 2 and the degree is 1, if I'm not wrong.
Okay, the order is 2, but degree is also again not defined because we are getting sine and the power, the differential is in its power. So in its parenthesis. So you can expand sine x also. This is also a series like exponential series. We have trigonometric series, sine x series, cos x series. So whenever the derivative is in the function of sine, you'll say the degree is not defined.
Okay. Got
Right,
it.
this is it has the same reason as the exponential one. As the exponential one has a series in which we have different powers of x. In the sine series also, you can like sine dy by dx can be written as 1 plus x, like dy by dx whole power something, then power something. So we'll get multiple powers of the derivative. So how we can, let's say that 2 is the degree when we'll get more, and when you see the series is never ending, so we cannot be sure that what is the degree. So we'll say that degree is not defined, right?
Yes, sir.
So all in all, there are the three cases that you want to know if the degree for whether degree exists or not. The first one is the derivative should not be in the function of exponential. So let's say you are getting like this e raised to the power y dash. So this is not defined in case of degree. Order will be defined, but degree will not. Second is like if you get log of y dash or something, derivative, we are just looking for derivative. Let's say in this fourth one, the question is y dash plus sine x equals 0. So this is a differential order. This is a differential equation. Both has order and the degree. The order
Degree.
is 1 and degree is 1
One.
because the derivative is free from sine function.
Yes.
Right. So the last case is like trigonometric function, like this one here. So if you have like some trigonometric function, sine, cos, or anything, and a derivative in its parameters, then this is also not defined. So these are just three cases, like in which the degree will not be defined because all of these are series, and in series we have multiple powers of x. So we cannot say for sure what is the power of the derivative here. So since that power is not defined, so degree is not defined. Right.